Okay, so we're on time to start. Without any further ado, I shall move on to this introduction to GVI second generation inverters. Thank you very much for joining me for this. Um, so I suppose before we start, a little bit about myself. My name is Tim Dobbin. I'm a product manager at EMPD, that's the Electric Motion and Pneumatic Division of Parker in Europe. I do both industrial and mobile inverters and have been doing so for about 7 or 8 years now. Before that, I worked in various other departments within Parker, but I've spent my entire career working really within inverters and the drives industry. I guess the one thing that I will say about working with the GVI as a product range is that I have the benefit of being there since the beginning. So I was involved with the in-motion GVI before we started developing the second generation GVI, and I've been with the second generation GVI since the very beginning. So unfortunately, I know an awful lot of technical information that I will try not to spend too much time on today. So what I wanted to do was cover really the GVI in 3 words. It sounds like a strange thing to do, but it's quite a good way to describe it. And then move on to an introduction to the GVI Gen 2. That's what it's really all about, which I will try and avoid talking too much about just bullet points of what it does and what it does not do. What I do want to move on to, though, is the idea of the GVI as a functional safety platform, as a component of a system, which I know Nils talked about at the very beginning, and then a little bit at the end on some system design considerations, not to scare you off, but to try and show you that we've tried to think about this. We're putting all those things together. Okay, so GVI in 3 words. So quite often people like to use the 3 words: safety, reliability, efficiency. They're the fairly standard things people say about the GVI, but everybody says that about their product. They all say, oh, mine is the most efficient, mine's the most cost effective. And they don't really describe the GVI that well. A better 3 words to use is the inverter, the platform, the component. The inverter, that's what it does. It's not a very exciting thing, to be perfectly honest. It's a box. It controls the speed of a motor, controls the torque of a motor. Now, there's a lot of clever stuff going on inside there. There's years of Parker experience poured into doing it, and it does it very, very well. But on its own, it's not really that exciting. Perhaps a more interesting part to it is the idea of the GVI as a platform, because that one, the GVI started life really as a functional safety controller. That was the idea, to build an inverter around that, to give ourselves a platform for the future that had a very high level of functional safety in it, but also something that could then migrate onto other products, not just inverters. A lot of the functional safety was developed in conjunction with Parker's aerospace division, something that not many companies have, an aerospace division. So we had that knowledge and we used it. And then finally, possibly the most important thing and the most interesting thing is the GVI as a component. We didn't develop the GVI to be a box that we sell off the shelf like we would do with an industrial inverter. It's designed to be a component of something else. It becomes so much more than just an inverter when you start integrating it with other things. And it's that integration which is really, really important. So the introduction part, unfortunately, this is the bit where I go through the bullet points, but I could talk about this for hours. I don't have very much time to do so, so I'll try and be brief. So scalability, I guess, is the first thing that I would want to talk about here. It comes in 3 sizes. Motors come in different sizes. Bruno and Frank just did a session on the GVM, and it's different diameters, it's different stack lengths, and it's different power ratings. And it's the same with the inverters. You don't want one big inverter that has to cover everything. So we started with the 3 sizes. In the future, there will be more. Similarly, we have to cover a large amount of different battery technologies. So we have a fairly wide operating range there, anything between 200 and 800 volts. And again, in the future, because it's a platform, it will go higher. And one of the key things that I mention quite a lot, because nobody has ever said this is a bad idea, is the common front-facing connectors across all of them. That means you could start with one size and move to another size without any problem whatsoever. They all have safety on board, but because we're aiming the GVI to be a component of a system on any electrified system. We've had to aim for both machinery directive standards and automotive standards. So it has both 13849 and ISO 26262 safety on board. That wasn't easy to achieve. We also have a safe active discharge system and configurable HVIL. So again, it's that idea of having it as part of a system, being able to integrate it with as many different things as possible. And really important for us is that high speed over voltage protection, which I'll go into a little bit more detail on later. But it's basically something we needed to have because the GVM motor, which was designed to control, is a very capable high speed motor. However, that comes with some challenges when it comes to the inverter. And then the final thing that's important is the powerful tools. Something that I found that when I moved from the industrial world into the mobile space is that the level of tools that people provided just weren't there. They're getting better across the board. But just because a mobile application is typically more complicated, more difficult to achieve than an industrial one, due to mainly a lack of standardization, it doesn't mean the tools have to be horribly complicated and engineering level to go with it. So we've tried to develop something that's quite configurable, that has multi-level user access, but also has some powerful tools like the scope for commissioning purposes and the black box data recorder. So what else does it have? So no presentation on an introduction to a product would be complete without a list of bullet points. So there they are. They're not in any particular order. Obviously, I don't think that the IP6K9K is the most important factor when it comes to a GVI. However, it is an important thing. It's effectively a de facto standard. Having all the connectors on one face, as I mentioned before, having them all on one face is something that everybody thinks is a good idea. Not only does it make it easier to install it or extract it again if you ever have to, but it makes it easier to calculate the footprint. It means you can orientate the inverter any way you like when you install it. And because all the cables, the pipes, everything all come out that one side, that's the area of space that you have to focus on for those kinds of things. We have power lock connectors because they have the built-in HVIL, and they're very reliable, quick to connect and disconnect. Something that isn't necessarily true when you have to deal with glands and plates and bolts and things. Similarly, the coolant is done through push lock connectors as standard, but they are replaceable. Not everybody wants that particular type of connector. You may prefer a male barb, for example. But because we use a standard port connection, the same one as the GVM, it means you have that flexibility. You can change them very easily. We've also chosen, wherever possible, standard connectors, standard fixings, so that you don't have to have an installation kit, for example. All these things are readily available. Excuse me. There are two CAN interfaces, a J1939, which is also 76 capable, and a CAN open. There are in fact two distinct ports. So one is the CAN open port, the other one is the J1939. But both of them can be used for the programming tool, which uses UDS over CAN. So you always have the ability to connect two things at the same time. They're both isolated and effectively independent from one another. Another little feature on the I/O, you'll notice it has two I/O connectors on the face. One of them's for the motor, one's for the vehicle harness. So again, a lot of those signals pass through. The HVIL, for example, comes into the vehicle system through the vehicle connector and out to the motor through the motor connector, keeping your wiring harnesses as simple as possible. I mentioned the safety before, so they all have this ISO 26262 capable tri-core processor. It's a very, very powerful thing. And that enables us to do things like monitoring the active discharge circuit to ensure that that's working safely. We monitor the resolver feedback to a very high level of integrity. And that little piece of patented technology is something really rather fundamental to the way that the GVI manages its safety. It's all about that integrity of feedback signal. So you know the motor is doing exactly what you tell it to do at any given time. The overvoltage protection that I mentioned before, that's a big deal. And in order to ensure that that is as safe as possible, there's a redundant built-in power supply as well. So you have the 24 volt or 12 volt auxiliary supply to the inverter, But once the high voltage DC is on, there's a secondary power supply in there. So even if you pulled all the connectors out of the front of the inverter, the processor stays up, everything stays safe. I guess the last 2 points I'd like to mention from the bullet point list are the filters. So of course, it has an EMC filter on the output side, but it's also got filters on the DC side as well. And that's very important when it comes to protecting your battery against DC ripple. When you have just the one inverter on a system, the switching of that inverter will create little ripples of DC on your DC bus. However, if you have multiple inverters on your system, just like the waves on the ocean, those can add and multiply and lead to some quite damaging currents. So we've filtered against that. And the final point is the high-speed motor control. And this is something that differs quite a lot from the GVI Gen 1 in that where we move into the field weakening area, we have lots of experience from our industrial products of doing that. And in all of the testing, those customers that have been using it so far have always commended it as the biggest step forward over the GVI Gen 1. Okay, I mentioned the idea of a functional safety platform. So I'm going to talk a little bit more about that. I'm not going to talk through a big list of bullet points here because actually it's not very interesting. The purpose of this slide is really to show you that we've put a lot of effort into this so that you don't have to. Part of that is, again, when you use the GVI or any inverter as part of a system, that system has to be safe. So the safer your component out of the box, and the easier it is to interface and control those safety functions, then the easier it is to make your complete system safer. And I know Nils earlier spoke about different standards, C standards, for example, that you have to meet. By focusing on the top level standards of the Machinery Directive and the ISO 26262 automotive safety standards, we haven't drilled down into different C standards. We haven't looked at agricultural standards, for example. But what we have done is given the highest possible level of safety integrity at those top level ones, safe in the knowledge, therefore, that we will be able to cover whatever the C standards throw at us afterwards. But also this functional safety platform, it enables us to integrate quite nicely with ICANN safety controllers, for example, and also it enables us to take that platform forward. So as as technology changes, again, it was mentioned earlier how quickly the electrification industry is changing. We have to be able to change quickly with it. So again, having that very powerful safety platform at the very core of the product makes it a lot easier to move forward with that. Now, probably as I say, the most interesting part, the part that makes the GVI really come alive, the GVI as a system component. So these are icons we've used many, many times before, and the interconnections between them. To make the GVI truly come alive, after all, without the rest of the system, it's just a very expensive paperweight. It needs to interact with the other components of the system, and it's been designed to do that from the very, very beginning. So, for example, we take our ICANN controller, we develop ICANN blocks specifically for the GVI. We have the same communications protocols between the controller and the GVI, and we have the power to create those interfaces for the ICANN environment. You can then have either the J193976, you can have CAN open, you can use a safety controller or not. They'll all work the same way with the GVI. Then moving on, you've got the GVI then has to have matched plugs with the GVM motor. Nobody wants a different set of plugs at either end of the bit of cable. The signals, obviously, we have, or rather had the ability to design our signal interface to the motor to match what already existed in the motor. There wasn't any form of interfacing or changes required there. And most importantly, of course, is the motor control of the GVI could be designed specifically to control the GVM motor as well as it's physically possible to do so. Then that functional safety of the GVI ultimately is there to keep the motor safe, whether that be voltage, torque, speed, whatever it is. And that's all achieved by having a built-in motor database. Again, something that unless it was part of a system approach, you wouldn't have. Then moving on again at the motor end, you've got the match plugs, etc., etc. I could go on and on, but really, I could have drawn this perhaps as a spider's web would have been a better way to describe it, because of course all those interlinks. You don't start with a controller and go to the inverter and go to the motor. It all works back the other way as well. And the hydraulics have to talk to the controller has to talk to the GVI. You could have the GVI talk to the hydraulics. It all interconnects some way. But the important thing is that we've thought all of this through for you, and we have the tools, we have the experience to be able to put all of these things together. So you're safe in the knowledge that they all work together as they should do before you've even started. So before you start, system design considerations. This is the bit where it gets very, very complicated, because although the inverter is just really a grey box, there's nothing particularly exciting about an inverter. There is a lot of stuff that goes on inside it. And when you start looking at your system design, there are a lot of considerations, and a lot of that is circular as well. When you change one thing, you have to go back and look at something else. Now, as I mentioned at the beginning, this list of horrible things that you have to consider, and it's just scraping the surface of the list really, isn't here to scare you off the idea of electrification at all. And it isn't here to make you go away and start thinking and worrying about all of these kinds of things. It's here to tell you that we've thought about all of this stuff beforehand. So, as I mentioned before, adherence to standards, that's a very important thing. I guess ultimately one of the most important things. It comes only after having a system that actually does what you want it to do. But you have to be able to meet those standards, otherwise your machine isn't any use to anyone. You've probably already selected your battery voltage by the time you get to looking at an inverter, but it is important to fully understand what that really means. For example, we quite often get asked about higher voltage ranges or an 800-volt battery. What's an 800-volt battery? Is that 800 volts when it's fully charged, when it's fully depleted? It's nominal voltage. You have to think about all of these things and how you protect it. Not so much with fuses, but I'm thinking about when it's actually connected to the machine. How do you ensure that you don't pull too much energy from the battery and overload it? How do you ensure that if something goes wrong and you have a load dump, that battery is protected? You also have to protect your battery against fault currents, ripple currents, the high-speed overvoltage. Again, this concept that a permanent magnet motor can generate some very high voltages if something goes wrong and you lose control. You have to protect the battery from that. You then have overload cycles, which of course inverters are very well equipped to deal with, but you have to consider the recovery cycle from that. You can't overload. It has to have rest periods. So all of these things, they all add up. I could go on again. I could talk about this for hours because I'm far too involved in the GVI really. But again, my message to you is really that Parker have thought about all of these things in the design of the GVI, and we've thought about the design of the GVI as part of the wider system. And hopefully that gives you the confidence to come to us, talk to us about your application, and allow us to use that set of tools and expertise to be able to work with you to specify a GVI, rather than just looking at that headline set of figures that says it's a 650-volt inverter, 250 amps, for example, yes or no. There's a lot more to it than that. And that's the part where we can really help. Okay, I've gone too far there. Any questions? If not, I have a couple prepared because there were perhaps a few things that I didn't get to cover. Okay, well, while I wait for you all to think of something, one of the first questions that we often get asked about is the CAN interface. I mentioned before that obviously it's designed to work with the ICANN controller, but what if you're not using an ICANN controller? What does the CAN interface look like? One of the big problems with J1939, for example, is that it wasn't really designed for electrification. Some of our engineers are actually part of the working group to try and standardize the J1939 for use with inverters, but it isn't quite there yet. So what we have is we have a proprietary CAN interface. So we we have the basics there, the things that you need. But most importantly, we also pass back and forth a lot of the safety information across that CAN interface. But unfortunately, what it doesn't do is it doesn't comply with a J939 standard, because really there isn't one. I guess another question is, how do you use the GVI as a generator? So again, this comes back to the fact that it's actually quite complicated because of all its safety features. I know that Bruno will have talked about using the GVM as a generator and how it has the same efficiency working as a generator as it does with a motor, which is quite an important thing to have. And of course, because the GVI was designed to work with the GVM, then we have the same thing there. It has all the same features, the ability to control it with the same level of efficiency, the same level of control as a generator. But again, there are considerations that you have to make when using it as a generator. One of the things that people will always try and do is to try and save money wherever possible and leave the battery out, for example, and have one large generator with lots of perhaps smaller EPTOs or smaller inverter-driven motors hanging off just that one DC bus. So you have a combustion engine that's providing the power to the system, and everything else feeds off of that real time in live. It can be done, but it takes a little bit of extra thought. Okay, well, still no questions for anyone else. I'm perhaps a little bit ahead of time. So thank you all very much for joining me, giving me 20 minutes to talk at you about the GVI. And as others, I'm sure will have said, that my details are there on the screen. If anybody wants to ask me any more questions or wants to give me several hours where I can talk through every last detail of the GVI, I'd be very happy to do so. But unless there's anything else, I'd ask you to click the little button in the corner of your screen, go back to the main room, where I'm sure they'll be starting again any minute now. Thank you very much.